Hi everyone, here is our last video on regressions, and our attention this time will be focused on a regression model's efficiency. When we examine simple regressions, we mentioned that R square, the coefficient of determination, can be used to analyze the predictive performance of the regression model. However, when models are composed of different numbers of variables, statisticians suggest we use either the adjusted R-square or other indicators such as the AIC or BIC indicators. In the template that you are provided with, under the data worksheet, you will notice that the performance indicators are provided in the adjustment section, with the adjusted R-square, the AIC, and the BIC that are provided. A regression model is considered a better predictor of Y when the adjusted R-square increases compared to another. However, improved models will lead AIC and BIC indicators to decrease. So these three indicators do not measure in the same manner the performance of a regression model. It may occur that these three indicators disagree as to what the better model is. Improving the efficiency of a multivariable model can be accomplished by adding new variables, so perhaps thinking of factors that were not initially in our regression data, by adding nonlinear forms to current variables, by adding interactions, so binary and quantitative variables combined, or by removing variables that were non-contributors to the model. Regardless of how you choose to approach this, you want to keep an eye on the measures of efficiency, which will let you know if you are making progress. One way of improving the efficiency of a model is to add nonlinear forms of variables that are already in the model that you are working on. When you examine the scatter plots worksheet, you will sometimes identify variables who show a trend that is potentially not linear. For example, when looking at the scatter plot of salary versus experience, you can tell that the scatter plot takes on some form of curve. It seems concave down, and perhaps some of you may even be tempted to incorporate the variable experience squared by saying that the shape is looking parabolic. There's a lot of intuition, obviously, behind this guesswork. Back in the data worksheet, we have the current indicators of performance. So 80% for the adjusted R-square, 982 for the AIC, 1007 for the BIC. Now, as we add a new variable called experience squared, then you can observe that the performance indicators have changed. The adjusted R-square has gone from 80 to 88%. The AIC and BIC values that were 982 and 1000 have dropped to 933 and 960. In other words, all three indicators show an improved model by adding experience squared. You can actually improve the efficiency of a model by also removing non-contributing variables. Non-contributing means the variables are not significant. In the results section, you can observe within the p-values that the least significant variable is variable sex, with a p-value the furthest from 1 or 5 or 10%. And perhaps removing variable sex from the data will allow a better estimation of an employee's salary. Let's see the effect of that. Back in the data worksheet, the current performance of the model has 88.68% for the adjusted R-square, 933 and 960 for the AIC and BIC respectively. Notice how in variable sex there is a 1 under x2, meaning that yes, we do want to include sex in the model for now. Once we remove variable sex, the performance indicators have changed. The adjusted R-square made a slight gain from 8868 to 88.80%. The AIC value, who was at 933, has dropped to 931. And the BIC index, whose value was 961, has dropped to 956. So once again, all three indicators will inform you that removing variable sex has been a wise decision in terms of creating a better predicting model. This is what we call the backward elimination method. It consists of removing variables from the model one at a time, starting with the least significant variable, until only significant variables remain. Where you stop may depend on the alpha you've chosen. Now, this approach will not necessarily result in the most efficient model, but it certainly will be one that is reliable. Here is the result of the process of eliminating variables using the backward process, and we have been left with experience, degrees 2, 3, 4, 5, and experience square as the significant variables. Here are the levels of performance given by the three indicators. The adjusted R-square has gone up to practically 89%. The AIC and BIC indicators have dropped to lower levels that they were before. So this would seem to be a model that we could use to make predictions with quite some accuracy for the salary of British teachers. To actually calculate a predicted value for a teacher's salary, you can use the predictor worksheet and incorporate the values you want to assign to the different variables themselves. So an employee that has 20 years of experience means that their experience square is 400. The 1 that has been placed in category degree 3 means that this employee has a diploma in that specific category. We predict that an employee with 20 years of experience and degree 3, or actually I should say the employees with degree 3 and 20 years of experience would have salaries of $2,500 per